Hi, this is Josh from Over the Shoulder Coding, where I help you prepare for software engineering interviews by guiding you through solving real problems. Today, I'm taking the LeetCode add two numbers problem and adding a twist to make it more realistic and simulate what you might actually go through in a real engineering interview. So the problem starts out pretty simple. We are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order and each of their nodes contains a single digit. Add the two numbers and return it as a linked list. So, for example, we might have the list 243, which represents the number 342. So 2 is in the ones place, 4 is in the tens place, and 3 is in the hundreds place. And we want to add 564 or 465. And the output should be 2 plus 5 is 7, 4 plus 6 is 10, so we put a 0 here and carry over a 1, add 3 and 4, which is 7, plus the carryover is 8. So we get 807. So the algorithm I just walked through basically is adding each element in a node and carrying over 1 if the previous element was greater than 10, reducing that by 10, and then adding the next pair of elements. And if we had an extra node here, like 5641, that would be 1465 instead of 465, then it'd be 1807. And once we get to the point where maybe 243 is length 3 and 5641 would be length 4, we don't need to be adding both at the same time. We can just add one list to the appending output. So the first way we're going to solve this is an iterative approach. We could take a recursive approach because solving 4-3 is a subset of solving 2-4-3. So you add 2 and 5, you'd get 7. Then you can do the same thing on a subset of the problem. And you can do recursive approach that way. But in an interview, you'd want to go through and do the most simple solution first and improve on it if you have time or your interviewer asks you to. It's a lot easier to debug and code something that's simple than to jump right in and try to do the most elegant or the most complex solution right away. So definitely do the brute force solution first. So we're going to start out with a list that we're going to output. So this is going to be the sum. And it's going to start at 0. And at the end, we're going to also return it. So let's just run our code really quickly to see what happens. All right, obviously it's incorrect, but we can see that our input would be 243564, these two nodes, and then our output would be 0, and the expected output is 708. So let's say our current place is the beginning of this sum list. Because we want to keep track of where we're at in this singly linked list. So we want to keep track of 7, and if we move, we want to keep track of 0 and keep track of 8. So we'll move by referencing the next node in the list node. So while both lists still have elements, we're going to add the two elements of the list together. So while L1 is not none and L2 is not none, we're going to add L1 and L2's value to current place's value. And if current place is greater than or equal to 10, like in the scenario 4 plus 6, we'll subtract 10 and make a carryover. So here we're starting off the next one at 1 instead of 0. So we would have 1 plus 3, then 1 plus 4 would equal 8. Otherwise, if the lists L1 and L2 have more elements, we want to keep adding the rest of those elements. So we're going to start the next place at 0. So 2 and 5 is 7, and it's not greater than or equal to 10, but L1 and L2 have more elements, 4 and 6, so we're going to start the next list node at 0. So that way they can add 4 and 6 to it, because if we wouldn't have made a next, in the next line, the next iteration of this while loop, current place would be null, and we would try to get a value on a none type and throw an error. So we're going to, at the end of this while loop, just go to the next node. All right, so let's try it out now. Oops. All right, looks like we passed this test case. And the test case is 2, 4, 3, and 5, 6, 4. But what if we have lists of different lengths? Well, what happened? Our output would not be the same as our expected output, because we're only iterating as far as where both list 1 and list 2 have nodes. But after we get to 4 and 3, list 1 doesn't have any more nodes. And so here we make another node, 0, but we don't do anything with it. And the expected output is actually 1 plus nothing should be 1 instead of 0. So after we exit this while loop, when only one of the lists has elements, we are going to use that remaining list as the remaining digits and add those to our sum list. So we're going to grab whichever list is not empty. If L1 is not none, if L1 is not none, we'll make remaining digits L1. Otherwise, if L2 is not none, we'll make remaining digits L2. And while remaining digits is not none, while we still have more digits to go, so like 1 over here, we're going to basically do the same thing we did here, except with just one list. So if we need a carryover, the current place value is greater than or equal to 10, we're going to carry that over in the next node and subtract 10 from the current place value's value. Otherwise, if there are additional nodes in the remaining digits list, we're going to make the next node in our sum list 0 to be able to add that to it. Then we're going to move on to the next nodes in our list, and it should work. So we proved through the test case we're able to add two lists together. Then when only one list still has elements to add, we're going to get that as remaining digits, and then do the same while loop but just for one list, and then return the total sum at the end. So let's test it out. Great, so it looks like we got matching output, but what if we had a carryover? So what if we had 9 here and this was actually 6? So this would carry over and we should have 10,000 instead of 1,000. So it also works with a carryover. This is the type of proactive testing that your interviewer would want to do on your own. You would provide your own edge case and test against it to show your interviewer that you're thinking about what could go wrong in your code and checking it, and if it does go wrong, you can go in and debug and fix it. So that's the iterative approach. And we're going to move that off to the side, or we'll submit it now and see how it goes. Cool. So it worked. It was about 20% faster, or faster than 20%. What if we ran it like this? It's definitely faster. We're probably in like the top 60 something percentile, which is not bad, right? We're doing 2 while loops. I mean, it's an O of n solution where n is the length of the largest list, either L1 or L2, because you iterate through both of them and then you iterate through the remainder of whichever one's longer. All right, so what if we did it recursively? So what we want to do is we want to solve 2 plus 5 and we get 7, and then we're going to solve 4, 3, 6, 4, which is a subset of this 2, 4, 3, 5, 6, 4 problem, and then return that and then add that to the 7 node. So the 3 plus 4 is going to be 8, and then that's going to be added on to this this 0 node, but we have to figure out how to do a carryover. So as we're iterating down this chain, we're going to solve 2 and 5 first, and then we're going to say whether or not there's a carryover to solve 4 and 0, and there's or 4 and 6, there's no carryover, so 4 and 6 is 10. We do define a carryover, so in the sub-problem of 3 and 4, we need to start the problem off with a carryover. So in this helper method, we're going to define whether or not there's a carryover. In here, we can start calling add two numbers recursively with no carryover. And for our base case, let's say we get down to 3, 4, no carryover. We need to be able to return and exit and then go back up this stack and return 8 to 0, return 0, 8 to 7, and then return 7, 0, 8. So if we're at the end, meaning we've added all the things together, then list 1, list 2 should both be none, and we should have no carryover. So that's our resolution, the base case, the terminating condition of our recursive function. Now, if carryover is none, but at least L1 or L2 is not none, meaning that we have elements to add, we need to make an element to start the adding, just like we did here with current place.next equals the list node carryover, or current place.next equals list node 0. We're going to make that starting element in the output list's next value. So if it's unspecified, then we're going to say carry over equals list node 0. So in this scenario, 2 and 5 yield 7, and then we're going to call this recursively with no carryover, so it's going to be none, but L1 and L2 are going to exist, and carryover is going to be none, so we need to iterate it, or we need to create it, otherwise we're going to get a none type error when we try to add L1 and L2's values onto our new elements values. And in the case where we add 4 and 6 and get a carryover would have been list node of 1 value, so it wouldn't have entered here. So if L1 is not none, we're going to add L1's value to this carryover. That's why we needed to initialize it first here. And we're going to do the same thing. We're going to add L1 and L2 to this. And then we're going to make the next carryover. It's going to start at none, but if the current carryover, or the current element we're at right now, and you can think of carryover either as the current node or the carryover from the previous parent function. So here, if the current node is greater than or equal to 1 or greater than or equal to 10, we need to subtract 10 and then make a carryover node for the next node that we're going to iterate on. So we're going to point the current nodes next to self.add two numbers recursive L1.next and L2.next. And so we're going to call this, and we need to return the current node. So when we call this on the subproblem, we should get 0, 8 back, or at the end we should get 8 back. And then we're going to turn that node to 0 and add 8 to 0's next. So then we link 0 and 8, and then we return it to 7, and we link 7 with 0, 8. So let's try it. Oh. mistyped. Okay, so we're trying to get next on a none type. Let's print everything that could be none. So the first one, we would print carryover 0, list 1, list 2. Next carryover, it's none. And then list 1, or carryover, list 1, list 2. Next carryover. Oh. Let's print the value. Let's not print next carryover. So it is none sometimes. So you get 725, 725, then we get 046, then we get 1, 6, 4, and then a 0. Okay. So let's go back to the original test case and see what's going on. We get 725, which is expected, and then the next values would be 4 and 6 that we're adding. Then that makes 10. We subtract 10, we get 0 from adding 4 and 6, and the next value would be 6 and 4, 1, 6. Let's change this back to the original test case. Just so we can match it up there. So here, let's look at what we're printing at the end. First we start with 725. The next values are 4 and 6. That makes 10. So we subtract 10. That was 4 and 6. The next two values are 3 and 4, which with the carryover adds up to 8 from adding 3 and 4. But 3 and 4 don't have next values. So when we call add two numbers recursively, then we enter here with none values. That's where we had the issue. So here will be, there's no next, so it would print out an error. So let's run this again. All right, so we're going to see what the carryover or the current node's value and next node are. So it's 807. 8 has no none. But it's not being returned. Or it is returning because it's recursive, but we're not returning it here when we call it, so we need to just do that. And now it should work. Okay, so it works, but we haven't tested it with lists of differing size. So if we do it with 1, we run the code. Okay, so we have attribute error, none type, object has no attribute, next. So here, let's print it out again. Okay, so we're getting to 834, and here L1 243 doesn't have a next node, but 1 is the next node after 4, so this would not be null. This would be null on the next call, so that here we would get not null, or L1 would be null, L2 would not be null. So we'd skip this step, we'd go all the way down here, and then we have carryover value, and then L1.val is null. So we wouldn't be able to call null.next. Got it. So what we're going to do is we're only going to increment L1.next if L1 exists. And if L2 doesn't exist, it's going to continue being none. We're not going to call next on a none value. All right, looks like that worked. And let's do our final test case where there's a carryover. And looks like it's the same. All right, so let's submit it and see how we did. All right, so the runtime was a little bit slower than the iterative approach, but you know, it's recursive, it's elegant. Your interviewer is probably going to be slightly impressed that you came up with a recursive solution, but in terms of performance, they're both O of n, so there's not really that big of a difference. So, you know, could it be faster? Your interviewer would ask, could it be faster than O of n? And the answer is going to be no. You're not going to be able to do a solution that's faster than O of n because you have to hit every single node, add them together to see what's going on. So how does the interviewer make this question tougher? Well, there's one more thing the interviewer can do to make this more difficult, and that's what if instead of just adding 2 numbers, we added n numbers together. So instead of 2 linked lists, L1, L2, we had n linked lists. So instead of having 2 parameters for this method, or in the recursive definition we had 3 numbers, we had add multiple numbers. And we had a list of add-ins, which are the numbers that are being added together. So if you do like 2 plus 4, 2 and 4 the add-ins, just like factors to a product. So add-ins in this situation is going to be a list of list nodes. and we still want to return a list node. So how would we do this? Let's call that. So how would we add that together? Well, we'd probably do a lot of the same stuff that we did in the iterative approach. So instead of saying while L1 is not none and L2 is not none, maybe what we would do is while we still have elements in the list to add, so like 2 and 5 are still lists to add, then we would add each element of the list, so like 2 from L1, 5 from L2, to the current place value. So these two lines that are L1, L2 specific, they would go in a for loop for lists, right? And then after the for loop is done, we could check if current place value is greater than or equal to 10 and subtract 10 and make a carryover. But if we're adding a lot of lists together, then this could be maybe 20 or 30 or greater than 20, greater than 30. So instead of just a simple if to see if it's greater than 10, we're going to do while it's greater than or equal to 10 and continue reducing this number down and then making a list node where we maybe like have a carryover 2 or 3. And then instead of checking if the next list is or is not none, the next element in the list is or is not none, we would add those next elements, if they're not none, back to the add-ins, right? So that way we get back into this while loop, and instead of working with L1 and L2, we're working with the add-ins. So let's say we get to the end. In this test case, we have one of length 3, one of length 4. While we're at index 0, 1, and 2, we would be adding both back into add-ins and continuing on the while loop. But when we get to 9, it's only in one of the lists, so we would only add that list back into the while loop of add-ins that we needed to add to the final list. And so we wouldn't need to call this .next because we'd be adding it to the add-ins. But we probably would want to continue moving the current placeholder to the next placeholder. And yeah, when only one list remains, that's going to be handled by the while loop that we're going to use here. So let's try and code this up. So let's copy most of this over and see what we can do. So we're still going to start with a list of 0. We're still going to keep track of where we are in the list. But instead of this, we're going to say while there's multiple lists to add, while add-ins is greater than 0, we're going to make this a for loop. So for add-in and add-ins, we're going to do current place.value plus equal add-in.val. Great. And if the current place is greater than or equal to 10, we're going to subtract. So we said that we would turn that into a while loop. We're going to subtract 10. And we need a counter for the carryover. So we can say carry over equals 0. And we'll probably need that outside of this for loop because we want to make the carryover the next one outside of the for loop. So while it's greater than 10, we're going to decrement 10 and increase the carryover by 1. Now, if after adding all the addends, if the carryover is greater than 0, we're going to make a list node with the carryover and add it to the addends. So the next round of addends. So here, for each addend in the addends, we're adding that addend's value to the current place. Then when we've added all the addends, we can check if the current place value is greater than or equal to 10. While that's the case, decrement the current place value, add 1 to the carryover. If the carryover is greater than 10, go and add that amount of carryover in the next round of addends. So we also need in here to determine whether we can continue on a list. So like continue on this 2, 4, 6 list or the 5, 6, 4, 9. So if the addend that next is not none, if there are more things in this list to add, we'll add the next value into the next addends. So for instance, if we add 2 and 5 and got 7, and 2 has more things to add, we're going to add 4 and 6 to the addends on the next iteration to be added. So let's delete this for now. And return our sum list. And let's see what would happen. Let's say we are going through. If the carryover is greater than 0, we make a next addends and append it, but we never change our current place. So at the end of this while loop, we want to change current place equals current place dot next. That way we iterate on each while loop. And in order to avoid that none type error again, we're going to check if length of addends is greater than 0, meaning we have more things to add, like if we made a carryover and needed to add it, or we have more things in the list, so we're going to continue that. We're going to populate this next so that we're not going to get a none error. And we're never going to start the next at list node 1 because we're going to add the carryover to the list of addends as opposed to doing it here. All right, let's try it. Oh, looks like we exceeded our time limit. What about if we revert to the original test case? Okay, time limit exceeded. So what's going on? My guess is that we probably have an infinite loop going on somewhere. So this loop is checking for addends. Do we ever remove elements from addends? No, we don't. We make our next addends, but what we need to do is say next, or addends equals next addends. So that way, if we never added anything to next addends, so let's say the addend didn't have any more elements, so the list, the number 342 or 243 didn't have any more digits, and there was no carryover, then next addends would be an empty list. We'd replace that in addends, and we'd exit the while loop. So let's test it out this time. Okay, so we got the output, but we added a extra 0. So we need to move this if check after we replace add-ins. So here, if the carryover is greater than 0, we'll add next add-ins, we'll replace add-ins, and if the length of the next iteration is greater than 0, we'll go ahead and make the next placeholder. Otherwise, we'll let it be none, and then we should exit the while loop because add-ins is not greater than 0. Okay, looks like it worked. This is a little bit redundant with the while loop. Let's see if we can get rid of it. So why don't we just move this up? So we'll say next add-ins is greater than or equal to 0. This will happen because that's really what we care about. All right, well, it really doesn't make a difference. Let's submit our code. Okay, and this actually runs faster than half of Python 3 online submissions. So we did pretty well. Not only are we able to add L1 and L2, but if we had made a list L3, we would be able to add that as well. So I think we did pretty good. And this is an example of how your interview question might start off simple. Adding two numbers iteratively was pretty simple. The interviewer might ask you, okay, what if we could do it recursively? And we made a solution for that that was completely different from the iterative solution. They changed the question completely and asked us, what if we were adding n numbers? And we have to think about the question completely differently. Whereas in the past, we were doing simple if statements with if L1 is not none and L2 is not none. But here, we have no if statements on individual lists except to check if they're done. We think in terms of sets of lists or lists or lists of numbers to add. And for this algorithm, add multiple numbers, what would be the runtime? Well, it would be ln, where L is the number of lists of numbers we're adding. So like here, we're only adding 2, right? L1 and L2. But here we could be adding 10 lists. So L would be 10. And each list can have, on average, n numbers. So we're going to do ln additions of current place.val plus equals addin.val. And we're going to run through this while loop n times, where n is the longest length of any of these lists. So here, if we had one list that was just super long, something ridiculously long, we would have that many while loops. But in each while loop, we will still have a for loop over L, the number of lists. So for something where you don't know exactly what the length of each list is, you can say on average the length is n to make your explanation of time complexity a little bit easier. So that's how an interview question might go from something pretty simple and innocent to something a little bit more difficult, and then the interviewer might flip the question, change it completely, and ask you something that you might or might not be able to use your code on. So fortunately, we saved our code from the iterative solution. We can use it here, but it would not have helped us to have already had the recursive solution since we used a different approach. When your interviewer changes the problem like this, don't get flustered. Think about what actually is the difference. Remember that when we changed the question, we went back to our iterative solution and said, okay, what's the difference between adding 2 lists and adding n number of lists? And we actually copied over and saved a bunch of the code. So don't panic, think it through, and ask your interviewer for help if you're stuck. I hope you liked this question. Give me a thumbs up and subscribe to this channel if you liked it. Comment down below if you want me to solve other problems and if you like this type of content. Thanks, and I'll see you later.